All right, let's talk about what happens when your app gets a new neighbor, actually a new roommate, living right inside its Kubernetes pod. We're talking about the Istio sidecar. We're going to break down what happens when this sidecar moves in, what can go wrong, and exactly how to make sure they get along.
So the platform team comes to you and says, hey, we're adding your app to the service mesh. It's going to be great. You get all this cool security and observability stuff. But it feels like a pretty big change. And you're probably sitting there thinking, okay, what's about to break?
And this right here, this is the fundamental shift. Before, your Kubernetes pod was a pretty simple place. It was just a little home for your single application container. But after you join the mesh, your app gets that roommate, the Envoy sidecar. Now there are two of them, living together, sharing everything in that same pod.
Okay, so who is this new roommate, really? Well, the Istio sidecar is basically a super smart, really lightweight proxy. Specifically, it's an Envoy proxy, and its whole job is to sit right next to your application and act like its personal assistant for all things networking. Every single piece of data coming in or going out, it handles it.
All right, this is where it gets super interesting, because now that the sidecar is handling all the networking, the journey a request takes to actually get to your app is completely different. So let's follow one, shall we?
Okay, so check out this flow. A request comes flying in, it's headed for your app. But, and here's the magic, it doesn't hit your app directly. Instead, some clever networking rules inside the pod grab that request and hand it over to the Envoy sidecar first. Envoy takes a look, maybe it checks a few security policies, gathers some metrics, does its thing, and then it forwards it to your application on localhost. Your app processes it, sends back a response, and yep, you guessed it. Envoy intercepts that response on its way out, too, before sending it off to its final destination. It's literally a gatekeeper for everything.
And this is the crucial point, the thing you really need to get. From your application's point of view, the entire outside world is just vanished. It's not talking to other services anymore, not directly. It's only ever talking to its roommate, the Envoy proxy, right there on localhost. I mean, think about that. It's a huge shift. Your application code doesn't have to worry about messy stuff like network retries or encryption or figuring out where other services are. It just talks to localhost, and the sidecar handles all that complicated external stuff.
Now, this new setup is really powerful, right? But it also comes with some traps, some really sneaky ones, and that brings us to a classic war story that I've seen so many teams fall into, the health check trap. It's the cause of some very, very confusing and frustrating restarts.
Seriously, I can't tell you how many times I've heard this story. The on-call engineer gets an alert, they spin up a war room, everyone's looking at red dashboards, Kubernetes is just killing their pods over and over and over. So they dive into the application logs and there's nothing wrong. The app is starting up perfectly fine. So what on earth is going on? The culprit in pretty much every single one of these cases is a classic race condition. A race between your application and its new roommate, the sidecar. Okay, here's how this plays out step by step. When a pod starts, both containers, your app, and the Envoy sidecar kick off at the same time. Now, your application might be super fast, maybe it's ready to go in just a few seconds, but the Envoy sidecar, it might still be warming up, initializing itself. So along comes the Kubernetes health check, right? Kubelet is just trying to do its job, pinging your app's health endpoint, asking, hey, are you alive? Are you ready for work? But remember our rule, all traffic goes through Envoy. If Envoy isn't ready yet, it can't forward that health probe, so the probe fails. Kubernetes sees that failure, assumes your app is broken, and does what it's designed to do. It kills the pod to try again, and boom, you are stuck in an endless restart loop.
All right, so we've cracked the case of the phantom restarts. Awesome. But there's another really practical thing we need to talk about. Your new roommate, well, it doesn't live in your pod for free. It needs its own resources.
And this chart, wow, it really lays it all out, doesn't it? Before, your pod might have been fine asking for, say, a quarter of a CPU and 256 megs of RAM. But after the sidecar gets injected, the total resource consumption for the whole pod goes up a lot. You are running a whole extra process after all, and you've got to pay for it with CPU and memory.
Yeah, to put a real number on it, a typical Istio sidecar will ask for at least an extra 128 megabytes of memory plus a bit of CPU. Now, that might not sound like a ton for just one pod, but if you don't account for it, you're going to have a bad time.
So the bottom line here, and you really can't skip this, is you have to update your deployment configuration. You need to increase the total CPU and memory requests for the pod to cover both your app and the sidecar. And don't just think about one pod. This is a cluster-wide cost. You multiply this overhead by hundreds or even thousands of pods, and suddenly you're talking about a real impact on your cloud bill and your cluster's capacity. If you don't plan for it, you're going to see performance throttling and maybe even pods getting evicted.
Okay, so we've mapped out the new traffic flow, we've sidestepped that nasty health check trap, and we've budgeted for our new roommate. Let's wrap all this up into a simple pre-flight checklist to make sure your app's move into the service mesh goes smoothly.
So here are the 5 big things your team should nail down. 1. Update those health probes. Give them an initial delay so the sidecar has time to wake up. 2. Name your container ports. Giving Istio a hint, like calling a port HTTP or GREEP, helps it do its job better. 3. Increase your pod resources, just like we talked about. Don't forget. 4. Make sure your app is resilient at startup. It shouldn't just fall over and die if it can't reach a database on the very first try. And finally, number 5. After you deploy, you have to verify. Use Istio's tools to actually check that traffic is flowing through that Envoy proxy like you think it is.
So, you follow that checklist and your app is ready for the service mesh. It's good to go. But that leads to one last question, and maybe it's the most important one. The tech is ready, but is your team? Because moving to a service mesh isn't just a technical change. It's a shift in how you think about networking, how you debug problems, and how you collaborate. Definitely something to think about. Thanks for joining me.